Great, hello, welcome back to Algebra 1. So yesterday we worked on adding and subtracting radicals together. Today we're going to be doing the same thing, because if we can add and subtract them, we can multiply and divide them. So today we're going to be working on multiplying the radicals together. So for our first example here, we're going to take a to the power of 1/2 and multiply it by a to the power of 2/3. Which is then we're going to have to, we can say that this is also a to the power of 1/2 plus 2/3. So then we're going to have to make these have the same denominator. So that's going to be a to the power of 3/6 plus 4/6, which will then be a to the power of 7/6. So since fractional exponents to be united by addition must be expressed with the common denominator, radicals to be united by multiplication must be expressed with the common root index. That is, they must be radicals of the same order. So let's also go down to our examples here. So example 1 is to multiply the square root of 7 times the square root of 5. So we can combine them together and say, well, that's the square root of 7 times 5. And that's going to be just the square root of 35. And since how 35 already is as far down as it can go, the square root of 35 would be our answer. Our second example is 5 times the square root of 3 times 2 by the square root of 15. So for this, what we're going to do is we're going to combine like terms, just like we're used to doing for binomials and stuff. We're going to combine like terms. So then we have 5 times 2 times the square root of 3 times 15. So then we can combine them even further and say, well, this 5 times 2 is 10 times the square root of 3 times 15, which is 45. And then we can say 10 times the square root of 45 can be broken into 9 and the square root of 5. And then 9 can be squared down, so this is 9 times 3, or 10 times 3 times the square root of 5, which then is 30 times the square root of 5. And there would be our answer. So our rule down here is the multiply the coefficients for the coefficient of the product and the radicands for the radical fact of the product, reduce the result if necessary. So that's what we did for that last problem, is we reduced it down as far as we needed to. So let's go over some of your problems together. Let's do question 5. So question 5 is 320 square root of 20 times 2 square root of 2. So like I said, we're going to combine like products. We're going to combine 3 and 2. So we have 3 times 2 times the square root of 20 times 2, which can then be combined even further to say, well, this is 3 times 2 is 6. 20 times 2 is 40. And then 40 can be reduced down. So we have 6 times the square root of 4 and the square root of 10. Because obviously 40 can be broken into 4 and 10. And then 4 can be squared to 2, leaving us with this, which then becomes 12 times the square root of 10 as our answer. Alright? Now, what are you going to do if you have a cubed root? So question 8 has a cubed root in it, and then it's 5, the cubed root of 5, times the cubed root of 25. Well, you're basically just going to leave it and do the exact same process for your problem. And it's just going to ultimately end up so that when you finish, well, the cubed root of 125 is just 5, so it's 5 times 5, which equals 25. So in this case, we end up with a whole number for our answer. So that's basically all you're doing today, is you're just going to take what you know about multiplication and what you know about using the radicals and stuff, and just multiplying them together. If it helps, put them in their more fractional form, if that helps. If it doesn't, then leave it in its radicand form. So for classwork today, you're going to do 1 through 17 odds. And for homework, you have 2 through 18 evens. And that's all you have to do for today. So I'll see you next time.